Hello everybody. I'm Chouiekh PhD student at the Sidi Mohammed bin Abdullah University, Faculty of Sciences, Dhar at the LISIC Research Laboratory. Before getting to the heart of the presentation of my research article, I would first like to thank all the others who helped me in the realization of this article and for allowing me to carry out this work. I would like to thank all the members of the jury for showing their interest in my study and for agreeing to participate in this conference. It is an honor for me to have the opportunity to discuss the results of my research with several researchers who have inspired me. I would also like to thank the entire administrative body and all those responsible for organizing this conference. I will therefore briefly present my research which titled Road Traffic Management Intersection Control, which will be presented according to the following planning. And first, we will start with an introduction. Then second, we will talk and present the simulation. Then we will define the reinforcement learning and we will explain one of the reinforcement learning algorithms or talk about the q-learning algorithm that we use it during this research. And we will display the results of the trained and evaluated model used. And I find by a conclusion. For introduction. Currently, moving has become an essential aspect of daily life, whether it is public transport or personal vehicles. This automatically leads to the problem of congestion, which contributes to the increase in the rate of accidents, which is why the management of road traffic and large route network remains an important challenge in many rare transport systems, and these congestions are generated due to intersections between routes. That is why in our research we are interested in the study and control of these intersections, where we present a reinforcement learning model that is the development and implementation of an q-learning reinforcement learning algorithm applying to route traffic simulation using the SIMU route traffic simulator. So what is an intersection? An intersection is a piece of real estate belonging simultaneously to two or more crossing routes, and this definition simultaneously obviously presents the aspects that creates a problem. Any attempts by the users of two interesting routes to use the intersection simultaneously leads to undesirable results. Therefore, control or design challenge and different approaches have been developed to eliminate the simultaneous use of the intersection route by two or more routes. The most obvious, but usually prohibitively expensive, the solution is to remove the intersection by providing pavement surfaces above or below each other on the same lot. This provides uninterrupted right of way on every route. In addition, Robertson developed a software tool called Transits, which determined the optimal parameters or traffic lights at fixed times and calculated the performance index of the signal network. And we know other approaches such as basic right-of-way rule, stop or yield control, and signal control. And final, we have other approach. It's approach speed control. Simulation. As we have not found a suitable data source for our targets, we then seek to use a suitable simulation means to model intermodal traffic systems, including route vehicles, public transport, and pedestrians. So we have decided to simulate road network data using the SIMO Road Simulator. Is a free open microscopic and continuous road traffic simulation suite designed to manage large road networks. And this research we carried we carried out simulation at Gaussian type intersections, such as example showing as the figure in the reinforcement learning. The goal of machine learning is to create intelligent programs. Through the process of learning and evolution, reinforcement learning is learning by interacting with the environment and observing the outcome of actions. It allows machines to automatically determine the ideal behavior in a specific context in order to maximize its performance. For this, a sample feedback of the results is necessary to learn how the machine should act. This is called the boss signal. It mimics the fundamental way human and animals learn. As humans, we can perform action and observe their results in our environment. Reinforcement learning can be characterized by the following steps. The agent observer observes and interests. An action is second. An action is determined by a decision-making function, police. Third, the action is performed. Fourth, the agent receives a result according to his environment. And the final results information given for this state or action is recorded. Q-learning algorithm is an off-police reinforcement learning algorithm that seeks to find the best action to take given the current state. It offers an idea of evaluating the quality of an action taken to move to a state rather than determining the possible value of the state to which is moved. When I talk to Q-learning, we have to specifically talk to Qtable, which is just a fancy name for a simple lookup table where we calculate the maximum expected future rewards for action at each state. Basically, this table will guide us to the best action at each state. And we should talk about Q function, which use the Bellman equation and takes two inputs, state and action. Using the Q function, we get the value of Q for the cells and the table. Model results. The environment is made up of states, actions, and rewards. The states and actions are inputs of the q-learning agent, while the possible actions are the outputs of the agents. In our research, the environment is the semi-environment and the agent is the vehicle. Our next task is for our agent to learn about his environment by implementing a k-learning model. The learning process will follow these steps. Choose a no-terminal random set for the agent to start this new episode. Choose an action, such as up, right, down, or left, for the current set. The actions will be chosen use a greedy epsilon algorithm. This algorithm will usually choose the most promising action for the agent, but it will occasionally choose a less promising option in order to encourage the agent to explore the environment. Take the chosen action and go to the next step. Then receive the reward for moving to the new set and calculate the jet lag. Finally, update the Q value for the previous sets. In this research, this whole process will be repeated over 10 episodes. This will provide the agent with enough opportunities to learn the shortest paths. Now that the Q table has been established over 10 episodes, let's see what the Q values are in the set of our illustration. The maximum Q value is -4568, so it seems that Q-learning has indeed learned that best action to take in the set of our illustration. Model evaluated model results. We can see from the evaluation that the agent's performance has improved significantly and that he has not included any penalty, which means he has performed the right actions. With Q-learning, the agent initially makes mistakes while crawling, but once he has explored enough, he can act wisely by maximizing rewards by making smart moves. As shown in the figure, the road traffic simulation finally. This email presentation sums up the results of the work of continuous work and hard effort that is part of the completion of research article that assess and develops the skills we have acquired during our graduate study. We hope it has provided you with important information and knowledge. Thank you for your thank you.